Okay, let's unpack this. When you look at a modern web app, it just feels, it feels like a fortress, right?
Oh, absolutely. The sleek dashboards, the instant load times, it projects total security.
Exactly. But if you could actually see the invisible war happening right underneath that polished UI, it is remarkably chaotic.
Chaotic is definitely the right word for it.
Right, because we trust these apps with everything, but the devs building them are just fighting this endless battle against alert fatigue, simple human error, and just garbage data being thrown at them.
It's an exhausting environment to work in.
It really is. So welcome to today's deep dive, everyone. We have got a really fantastic, custom-tailored stack of sources to go through with you today. It's basically a shortcut to understanding the crazy world of modern web application security.
Yeah, the source material you provided is a really fascinating mix.
We've got two academic studies, one on the habits of NPM developers and another comparing API fuzzing tools. And then we're combining that with some boots-on-the-ground guides from the Vercel and Next.js ecosystems, a dev community post about a huge real-world mistake, and a production launch checklist.
It's a great blend of theory and actual practice.
For sure. And our mission today is to connect the dots between how developers actually feel about security, the literal code-level mistakes they're making, how we can aggressively test for those gaps, and finally, the ultimate checklist for deploying safely.
It's a full lifecycle view. And to understand the code, we really have to start with the humans writing it.
Yes.
Yeah.
Section 1, the human element.
Hmm.
So the whole web essentially runs on the NPM ecosystem, right? Node Package Manager.
Pretty much, yeah. It's the foundation.
So we have this academic survey of 75 experienced NPM developers, and the data shows an immediate paradox. Like 77% of them say security is highly important.
Right.
But when asked to rate their own published packages, most of them just say they're somewhat secure.
Yeah, that gap between priority and reality is huge.
Wait, but if these are experienced developers who know security is essential, why aren't they fixing it? Are they just being lazy?
No, it's definitely not laziness. They're dealing with what the researchers call socio-technical security debt.
Socio-technical security debt. Okay, what does that actually mean?
Well, the researchers use this thing called the board account method to rank the developers' top fears. It's a voting system that weights preferences, so it gives a really accurate consensus.
Okay, so what are they afraid of?
Their top fears are supply chain attacks, dependency vulnerabilities, and malicious code injection. But, and this is the kicker, only 40% of them are actually satisfied with their current security tools.
Really? Only 40%?
Yeah. And it all boils down to alert fatigue. You see, tools like NPM Audit and Dependabot are everywhere now, but they generate a massive amount of false positives.
Oh, like crying wolf.
Exactly. One developer in the study even complained that, quote, 99% of vulnerabilities are idiotic noise.
Wow, 99%.
Yeah. So what's fascinating here is that the tools designed to protect us are actually overwhelming the humans who use them. When you get 100 alerts a day and 99 of them don't matter, you just stop looking at them.
Right, if my smoke detector goes off every time I make toast, I'm just taking the battery out.
Precisely. And that fatigue leads directly to basic mistakes slipping into the application code.
Which brings us down from the ecosystem level to the actual code. Vercel Academy outlines these 5 critical security gaps that happen when devs are just, overwhelmed.
Right, the foundational flaws.
Yeah, so there's no authentication, no input validation, no authorization, no rate limiting, and no error handling. But the error handling one really caught my eye.
Oh, the stack trace issue.
Yeah, exposing detailed stack traces to attackers. If your app crashes and spits out the exact file path and line of code, you're just handing a hacker a map of your backend.
It's basically a topological map of your server. You have to intercept those and just return a generic error.
But even if you do that, there's another massive trap. The dev community post in our sources highlights this really common blunder in Next.js. It involves the nextTpublic prefix.
Ah, yes. The environment variable issue.
Right. So if you prefix an environment variable with nextTpublic, Next.js bakes it right into the client-side code. And this author found their company's highly sensitive API keys sitting in the browser cache right under the next static folders.
In plain text, just waiting to be scraped.
Exactly. So, adding nextTpublic to a secret key is basically like leaving your house key under a glass doormat. It's technically outside, but everyone can see it.
That's a great way to put it.
If it's so dangerous, why does this feature even exist? Why would a framework let you do that?
Well, because sometimes the browser actually needs to know things. Like if you're using Stripe, you need a publishable key to tokenize credit cards, or you need a Google Analytics ID.
Oh, right. Okay, so some things have to be public.
Exactly. The danger arises when developers mix server variables with client variables in the same utility files. They get fatigued, they copy paste a prefix, and suddenly the database password is public.
So how do you stop that?
The Vercel Academy solution is strict boundaries. You use schema validation like Zod to strictly define what every variable is allowed to be before the app even boots. And if there's a contradiction, the build intentionally fails.
Okay, so we know developers are tired, and we know these code-level mistakes like exposed secrets and missing validation happen.
Yeah.
How do we actually find these gaps before the bad guys do?
We have to attack our own apps.
Right, going on the offensive. And that brings us to the API fuzzing study. So fuzzing, it basically involves throwing random, invalid, or even malicious data at an API just to see if it breaks.
Exactly.
Yeah.
Testing that no input validation gap in real time.
I mean, fuzzing sounds like letting a toddler mash a keyboard to see if the computer explodes.
That's honestly not far off. The researchers took a vulnerable app and unleashed 3 state-of-the-art fuzzers on it: EvoMaster, REST Test Gen, and Wrestler.
And the test results were wild. EvoMaster and REST Test Gen hit 100% endpoint coverage really quickly.
They did.
But, and I have to push back on this data here because this is where it gets really interesting. If EvoMaster hit 100% of the endpoints, how did it miss so many bugs compared to Wrestler?
It's a great question.
Because Wrestler only hit 71% coverage in that 1-hour test, but it found way more unique errors, like 140 bugs in Node.js and 164 in Python. How does that happen?
It all comes down to how they behave. EvoMaster acts like a speedrunner.
A speedrunner.
Yeah, once it finds one basic error on an endpoint, it just logs it and moves on so it can get that 100% coverage metric. It's very shallow.
Wow, okay. And what about Wrestler?
Wrestler acts like a relentless detective. It stays on a single endpoint, it combines invalid inputs, it changes data types, and it probes deeper and deeper into the stateful logic to find complex constraint violations.
So it's not just rattling doorknobs, it's picking the lock.
Exactly. And I always ask people, what stands out to you here? I mean, would you rather know every room in your house has a minor draft, or that one specific room has a massive structural flaw?
Oh, the structural flaw, 100%. Coverage metrics can be such a lie if they're shallow.
They really can.
Okay, so now we know how brutal fuzzing can be
Yeah.
and how it finds these deep logic flaws. How do we actually defend against it?
This is where we combine the defensive side of that fuzzing study with the Vercel production checklist.
Right, locking the doors.
Yeah.
So the researchers tested input validation libraries. They used Joy and Zod for JavaScript and Marshmallow and Pydantic for Python.
And the results there were incredible.
Yeah, they found that implementing full validation, which means checking the data types and the constraints like minimum and maximum lengths, resulted in a 96 to 98% reduction in errors triggered by those fuzzers.
It's a massive drop. It basically neutralizes the automated attack at the edge of the application.
Okay, let's unpack this though. If Zod and Joy are stopping 98% of these garbage inputs, why do we even need this massive Vercel checklist?
You mean the infrastructure stuff?
Yeah, like web application firewalls, content security policies, rate limiting. If the code is rejecting the bad data, why do I need a heavy firewall?
It's the concept of defense in depth. If we connect this to the bigger picture, think of Zod and Joy as the bouncers checking IDs at the door of your API.
Okay.
But rate limiting and the web application firewall, the WAF, they're the traffic cops stopping a mob from overwhelming the building in the first place.
Oh, because parsing all that garbage data takes CPU power.
Exactly. If 10,000 bots spam your Zod validation per second, your server won't get breached, but it will exhaust its CPU and crash. Rate limiting stops the DDoS attack before it reaches your code.
That makes total sense. And there's also that leftover 2% of bugs, right?
Yes. In the study, they purposely left out a few maximum value constraints, like on a shipping charge variable.
And the fuzzers still found it.
They did. Those tiny cracks are always there because humans aren't perfect. That's why the Vercel checklist reminds us about deployment protection and staying vigilant. They even referenced an April 2026 security incident bulletin just to prove that even huge platforms have to constantly adjust their defenses.
Wow. It really is an ongoing war. Well, what a journey today. We started with the stressed out NPM developer battling alert fatigue, looked at the sneaky danger of next to public variables, went through the chaotic stress testing of Wrestler fuzzing, and finally locked everything down with Zod and Vercel's production WAF.
It's a lot of layers, but they all depend on each other. And honestly, it leaves me with a thought I keep mulling over.
Oh, what's that?
We saw in the NPM study that developers absolutely hate the noise of automated security scanners.
Yeah, the 99% idiotic noise.
Right. Yet we also saw that automated fuzzers and validators are the only way to catch the millions of edge cases that a human brain just naturally misses.
That's true.
So as our applications scale, and as AI begins writing more and more of our baseline code, will we eventually need AI just to read the security alerts for us?
Wait, like an AI to read the AI's alerts.
Exactly, removing the human developer from the security loop entirely just to spare them the fatigue.
Man, that is a wild thought to end on. An entirely automated invisible war. Well, thank you so much for joining us on this custom deep dive. And seriously, for you listening right now, go check your .env files. Make sure your secrets aren't wearing an XT public name tag in your code base. We'll catch you next time.